Hi everyone, this is a quick tutorial on this super easy lesson, which is evaluate piecewise functions graphically. So first of all, what the heck is a piecewise function? Piecewise function. Well, that's a fancy name for a function that has pieces. So most functions that we look at are continuous functions, or continuous with some interruptions. So they go like this, or like that, or sometimes a line. And all of these, they might have a hole right here or something like that, but otherwise they're pretty much continuous functions. A piecewise function does not look like that. A piecewise function looks like this. So it'll say it starts here and it goes to here. And so the function is valid between these points. Let's call this -5 and -3. So you have answers between -5 and -3, but you don't have answers anywhere else on here. Okay. However, the same function could stop at -3 and it could start again and go the opposite direction right here. And let's just say instead of it could start again at -1 and go all the way out here to 3. But notice at 3, okay, this is a hole. All right, so the function has a definition between -1 and 3, but not at 3. At 3, the function is undefined. So this would be undefined at x equals 3. Now, just to make it a little crazier, all right, this function could start again down here and go to 5, and it would have a solid dot down here at 3. Okay, so if there's any solid dot, if there is any solid line or point, the function is defined at that point. And what does defined mean? Defined means it has a value. So put over here defined. What does that mean? Defined means, okay, defined means has an x value at that point. Okay, all right, so that's a little quick intro to piecewise functions. I'm going to get rid of all of that, and we'll go back over here, and we're going to do a couple of these problems. All right, so this one says find f of 9. So find f of 9. All right, so f of 9 is, I guess I need to write on this. There we go. Okay, so f of 9, I guess it's going to make me write on this side. All right, f of 9 is right here. All right, and so when we look at f of 9, and on this function, we see that f of 9 is equal to, is where y equals 3. All right, so we're going to say f of 9 is equal to 3, and that's going to be our answer. All right, get rid of this and come back over here. And notice it says you can have an answer that's undefined. We talked about that before. That's not going to be our answer this time, but it's an answer we could use in the future. Okay, so we're going to say f of 9 equals 3. Submit answer. Yes, that's our answer. And we get a green check. Let's go to the next problem. All right. So notice this is one of those I was talking about before. I'll write on the screen again. All right, this is one of those talking about before. So it has a hole here. All right, and another hole there. And so you would think, well, this isn't going to be defined at x equals 0. But up here, okay, it's defined, meaning it has a value. We're at y equals 1. Okay, so this function really looks like it's going to be continuous over everything. All right, but anyway, we're supposed to find f is -3. All right, so I'll use a different color here to make it easier to see. All right, there's f is -3 is right there. And so if I go up until I hit the line at y equals 3. All right, so f of -3 is equal to 3. All right. Let's go back over here, and we said that was equal to 3, and so we're going to submit that as an answer, and we get a check. All right, let's do another one here. F of -3. Well, that one's pretty easy. That one's also going to be -3. I go over to -3 and go down, and that's equal to -3. All right. I'm looking to see if they have maybe a tricky one in here. All right, this says f of -1. Well, that does have a point at f of -1, which is 4. So that one doesn't look very tricky either. And evaluate f of -4. Well, you know what? It doesn't look like any of these are very tricky, so I'll just let you check them out.